Hello, in this video, I'm going to present the complete workflow I made for the city bike data. So the problem we are trying to solve over here is we try to see what's the relationship between the daily weather information and the number of the daily bike trips we have. So we try to see whether we can build a model to predict the number of the bike trip based on the weather information of the day. And we limited the date to the non-weekends, meaning we only consider the weekday and which are not a holiday, because from our initial data exploration we find out the trip distribution is different from the weekday to the holiday and the weekend. So we limited our data set to only the non-holiday weekday. So as we can see over here, this part is mainly about data cleaning and data processing. So basically everything on the left-hand side of the percentage split P workflow. So our data source, which is the CSVs, we have all the data from 2013 July to July 2017. So as we can see, we first process the bike data. First of all we got the daily trip, and we do some formatting of the dates in the data, and then we add the day of the week into the data, and also we split the dates to two other columns, which is the month and the year. And then we try to filter out the holidays from the bike data. So we got a holiday data source. This is basically the 10 US holidays we have. And then first of all we do a format of the date as well, so that the date column in these two data sets is going to be consistent. So we have this filter holiday P workflow, and then we got the daily trips, which are not the holidays. And then we also have the weather information over here. We first of all, similarly, we format the date, just make sure they all aligned, be consistent, and then we drop some columns which are not really useful for our data analysis, and then we fill in some missing data. And then, as we can see over here, the filter weekend is after we filter out the holiday, we also filter out the weekend, and then we merge that with the weather data. So we have a complete data set which is clean and processed, which is we got the weather data. We got the daily trips with weather for all the days which are the weekday, which is a non-holiday. And then we do some date preparation, basically do some reorder of the columns, and then we go to this split. So at this point, every data we have from these resources, we merge them together and clean them, process it. And then we split this one based on a ratio, which is in this case is 80 and 20. So we use that 80 as the training set, and we use this 20 as the test set. So in this training set, each of this goes to a different machine learning model. So as we can see over here, we have the SVM regression, which is the support vector machine used for regression, and we have the RAP tree, which is a decision tree algorithm for regression. And we also have a linear regression and the M5P, which is a model tree. So basically what this means is also a tree algorithm for regression, but at the lib of each tree is a linear regression model. And each of the model, we have two outputs. The first one is basically the evaluation of the model, and the second one is the prediction of the model using the testing data we have. Another thing I want to point out is in each of the model, the training set was passed in and the training was done using cross-validation. Since we have relatively limited size of the data points, because even though we have almost 8 GB over here, but when we go to the daily trip, filter out holiday, and weekday, we only have around 1,500 data point, and then 80% of it is around 1,000. So we use cross-validation. In particular, we use the 10-fold, which means for this training set, we divide that to 10 different samples. Each time we use one as the testing set and the other one as the training set, and then to train the model. In this way, hopefully we can get some unbiased, not too overfitting model, and the performance of each model was output as well. So after this, let's see some sample run over here. This is basically all the output I have here, and I think we can go to one thing, which is, for example, the M5P tree, this one. As we can see over here, we have the correlation coefficient, which is 95%. This is basically tells us how correlation coefficient it is between the predicted value and the true value. And we also have some mean absolute error and so on, and relatively error. So we're going to use this to differentiate the performance of the model. In particular, we're going to use this, which is the square of this, which is the so-called R square for the regression model, tells us how well the variance of the data can be explained by the model. So the higher, normally the higher number it is, meaning the model is better. On the other hand, we also have the prediction output, which is really a prediction of the model. So as we can see over here, we have the true value here, and then we have the prediction value, and we also have the error. So we can do some calculation for the error to evaluate how accurate the model was doing in terms of prediction. So basically, we have two matrices here. One is in terms of from the training, the other is from the real testing.